In order to solve for a parallel circuit, we need to remember the three rules. Voltage is constant. The total current in the battery equals the current that flows through all the resistors. The total resistance is 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. The simplest parallel circuit possible consists of two resistors. We know this circuit is parallel because the long plate is the high potential or positive, the low plate is low potential or negative, so current will flow in a clockwise direction. Once it reaches the direction, it has the ability to go through R1 or R2. Since it has more than one path that it can travel through, this is a parallel circuit. When we work with parallel circuit, we look for the voltage because if we know the voltage, it is constant through all the branches. We know that the batteries is in parallel to R1 and R2. Since the battery has a voltage of 10, this tells us the voltage through R1 is 10 and the voltage through R2 is 10. So we can solve for the current in R1 because V1 is equal to 10 volts, R1 is equal to 10 ohms. So using Ohm's law, I1 is equal to V1 over R1, which is 10 volts over 10 ohms, which is equal to 1 amp. We could do the same thing for R2 because R2, we know V2 is 10 volts, R2 is equal to 20 volts, I2 is equal to V2 over R2, which is 10 volts over 20 ohms. And this is equal to 0.5 amps. So we know the voltage is 10 because it's in parallel. We know the current of resistor 1 is 1. The current through resistor 2 is 0.5 amps. The total resistance, we could either solve for the total current, then use Ohm's law to find the total resistance, or we could solve for the total resistance and then solve for the total current. I'm going to solve for the total current first because it's a lot easier to do. I total is equal to I1 plus I2, which is 1 amp plus 0.5 amps. This is equal to 1.5 amps. So total resistance is going to be voltage total over I total, which is equal to 10 volts divided by 1.5 amps. This will equal to 6.67 ohms. You can also solve for the total resistance. 1 over RT is equal to 1 over 10 ohms plus 1 over 20 ohms. Using the calculator, we're going to punch 10, use the reciprocal button, plus 20, reciprocal button. If I do that, I get the fraction 1 over 10 and 1 over 20 equals 0.15. So 1 over RT equals to 0.15. Since RT is in the denominator, we have to do 0.15, take the reciprocal button, and this will give us 6.67 ohms. Using Ohm's law, I total becomes V total over R total, which is 10 volts divided by 6.67 ohms, which will give you 1.5 amps. So what happens in this circuit is the following. We have 1.5 amp that leaves the battery. Once it reaches the first junction, R1 is going to take 1 amp, R2 is going to take 0.5 amp. When it reaches the second junction, these two are going to combine again and become 1.5 amp. The reason resistor 2 has less current than resistor 1 is there is more resistance in R2, which is 20 versus 10. The definition of a resistant or a resistor is to oppose the motion of current. The higher the resistance, the more it opposes the current, so the current will be less. This problem is similar to the problem we just did. Pause the video, solve it out, and check your answer. This is also a parallel circuit. The long plate is positive, high potential, short plate is negative, low potential. By convention, the current will go from high to low. When it reaches this junction, the current could go through R1 or R2 or R3. Since there is more than one path, this is a parallel circuit. So again, since voltage is constant, we're going to look for the voltage. Here, the voltage at the battery is given as 15. Since we know the battery R1, R2, and R3 are parallel, we know that the voltage through R1 is 15, R2 is 15, and R3 is 15. We could find the current through R1, R2, and R3 because we know the voltage and we know its resistance. So voltage 1 is 15 volts. R1 is equal to 15 ohms. So I1 is equal to V1 over R1, which is 15 volts over 15 ohms, which is equal to 1 amp. V2 is equal to 15 volts. R2 is equal to 10 ohms. So I2 is equal to V2 over R2, which is 15 volts over 10 ohms, or 1.5 amps. V3 is also 15 volts. R3 is 20 volts, or 20 ohms. So I3 is equal to V3 over R3, which is 15 volts divided by 20 ohms, equals to 0.75 amps. So now if I complete the chart, V is 15 for all of them because they're all in parallel. The current through resistor 1 is 1, through 2 is 1.5, and 3 is 0.6. Finding the total current first, then using the Ohm's law to find total resistance is easier. I total is equal to I1 plus I2 plus I3. This is equal to 1 amp plus 1.5 amp plus 0.75 amp, which is equal to 3.25 amps. So R total is equal to V total over I total, which is equal to 15 volts over 3.25 amps, and this will equal to 4.62 ohms. We could repeat the procedure to double check. So if I double check, this is 1 over 15 ohms plus 1 over 10 ohms plus 1 over 20 ohms. To find the total resistance, I'm going to use my calculator and the reciprocal button. And you would punch it in like this. Oops, there should be a plus. 10, reciprocal button, plus 20, reciprocal button, and you will get 0.217, but that is 1 over RT is equal to 0.217. So I have to take 0.217 and take the reciprocal. And when I do that, I will get the same answer of 4.62 ohms. I can find the total current. I total is V total over R total, which is 15 volts divided by 4.62 ohms. which is equal to 3.25 amps. Both methods will get you the same answer. Here's another example of a parallel circuit. Pause the video, solve, and check your answer. This circuit is a little different from the previous circuit because all the resistance are not provided. Even if the resistance are not provided, what you're going to look for is the voltage. Why? The voltage is constant. We know this is a parallel circuit. Why? The long plate is high potential, the short plate is low potential, so we know the current is going to flow clockwise. When it reaches this junction, it could flow through R1 or R2. Again, more than one path, it is a parallel circuit. What is given is V2. V2, the voltage is 5 volts. We know this circuit is parallel, so that means R1, R2, and the battery are in parallel. So if V2 is 5 volts, then V1 is 5 volts, and the battery is 5 volts. So we could find the total resistance because we know the total voltage is 5 volts. We know the total current is 0.75 amps. So R total is equal to V total divided by I total, which is 5 volts divided by 0.75, which equals to 6.67 ohms. We could also find the current through R1 because V1 is equal to 5 volts, R1 is equal to 10 ohms. So I1 is equal to V1 over R1, 5 volts over 10 ohms, which is equal to 0.5 amps. So if I complete the table, this is 6.67, this is 5 volts, this is 5 volts. We know the current through R1 is 0.5 amps. So again, just like the previous problem, we could solve for the total current and then use Ohm's law to find R, or we could use the total resistance formula and find R, and then use Ohm's law to find current. In this case, it is a lot easier if you find the total current first, because then you don't have to deal with fractions. So I total is equal to I1 plus I2. 0.75 amps is equal to 0.5 amps plus I2. So I2 has to equal to 0.25 amps. So now I can find R2 using Ohm's law, which is V2 over I2, which is 5 volts divided by 0.25 amps, which is equal to 20 ohms. Pause the video, solve for the missing variables, and check your answer. This is also a parallel circuit. The current will flow clockwise. High potential, low potential. At this junction, it could go through R1 or R2. Since there is more than one path, this is a parallel circuit. So again, in a parallel circuit, if all the resistance is not given and the battery is not given, figure out where we could find the voltage that is constant. V2, the voltage is given as 6 volts. Since the battery R1 and R2 are in parallel, the voltage that goes through R1 is going to be 6 volts, and the voltage that goes through the battery is 6 volts. Since I know that the battery's voltage, which is V total, is 6 volts, and I know the current total at the battery is 3.5 amps, using Ohm's law, I can find the total resistance, which is V total over I total, which is equal to 6 volts over 3.5 amps, which is equal to 1.71 ohms. So if I complete the table, I know the voltage is constant, so they're all 6. I know my total resistance is 1.71. I could also solve for R1 because V1 is equal to 6 volts. I1 is equal to 3 amps. So R1 is equal to V1 divided by I1, which is 6 volts, divided by 3 amps, which is 2 ohms. I could find I2 using the total current formula and then solve for R using Ohm's law, or I could solve for R2 using the total resistance formula. This is going to be a little bit harder because you are dealing with fraction. So I would solve for the total I equals I1 plus I2 because we know what total I is. That's 3.5 amps. That's at the battery. The current through I1 is 3 amps. So I2 is going to be 0.5 amps. So using Ohm's law, R2 is going to be V2 over I2, which is equal to 6 volts over 0.5 amps. That will give you 12 ohms. Here's another parallel circuit. Pause the video, solve, and check your answers. So this is another parallel circuit. Current is going to flow clockwise. High potential, low potential, high to low. Once it reaches this junction, it could go through R1 or R2 or R3. So there's more than one path for current to travel through. Since all the resistance are not given and the voltage is not given at the battery, we look at the resistors to see if voltage is given. If you notice, V2 is given. Since we know this is a parallel circuit, the battery R1, R2, R3 are in parallel. So they need to have the same voltage. Since the total resistance is provided at the battery, we could find the total current because V total is 3 volts. R total is given as 1.3 ohms. So I total is V total over R total, which is 3 volts divided by 1.3 ohms, which is 2.31 amps. We could also solve for R1 because V1 is 3 volts, I1 is equal to 0.25 amps. So R1 is V1 over I1, which is 3 volts divided by 0.25 amps. This is equal to 12 ohms. We could also solve for I3 because we know V3 is equal to 3 volts, R3 is equal to 5 ohms. So I3 is equal to V3 over R3, which is 3 volts divided by 5 ohms, which is equal to 0.6 amps. So if I complete the table, we know the current at R3 is 0.6. We know the total current is 2.31. We know the resistor at R1 is 12 ohms. Again, You could solve for the current first and then use Ohm's law to find R, or you could do it vice versa, find R and then use Ohm's law to find current. Since we don't want to work with fractions here, it's easier to solve for the current because we know I total is equal to I1 plus I2 plus I3. The total current was given as 2.31 amps is equal to 0.25 amps plus I2 plus 0.6 amps. That tells you I2 is approximately 1.46 amps. Now we can solve R2 using Ohm's law, which is V2 over I2, which is 3 volts divided by 1.46 amps. This will give you approximately 2.05 ohms. Pause the video, solve the missing variables, and check your answers. This is also another parallel circuit. Current travels from the high potential to low potential, so it's going to go clockwise. It's going to reach this junction right here and split into R1, R2, and R3. Here, the current is given, so we could solve for the total current using I total is equal to I1 plus I2 plus I3. You know the current through 1 is 0.5 amps, through 2 is 1 amp, through 3 is 0.75 amps, which gives you a total current of 2.25 amps. That is the current through the battery. Now we can find the total resistance because the voltage total is 2 volts. I total is equal to 2.25 amps. So R total is equal to V total over I total, which is 2 volts divided by 2.25 amps. This will give you approximately 0.888 ohms. So if I complete the table, it's 8. And the current is 2.25. Since we know the battery R1, R2, R3 are in parallel, and the voltage at the battery is 2, that means R1 has a voltage of 2, R2 has a voltage of 2, and R3 has a voltage of 2. So this is 2 volts, 2 volts, and 2 volts. I could now solve for R1 because I know V1 is equal to 2 volts, I1 is equal to 0.5 amps. So R1 is equal to V1 over I1, which is 2 volts divided by 0.5 amps, which will give you 4. I could also solve for R2 because V2 is equal to 2 volts. I2 is equal to 1 amp. So R2 is equal to V2 over I2, which is 2 volts, 1 amp, which is 2 ohms. I could solve for R3 because V3 is 2 volts. I3 is equal to 0.75 amps. So R3 is equal to V3 I3, which is 2 volts over 0.75 amps, which is equal to 2.6. I hope these slides give you a better understanding of parallel circuits. If all the resistance are given in a parallel circuit, find RT or REQ. They mean the same thing, the total resistance. Then look for voltage because voltage is constant in a parallel circuit. If you know the voltage for any of the branches, you could solve for the current using Ohm's law. If some of the resistance are given, determine the voltage. See if a voltage is given in a branch, or if current and resistance are given, so you could determine voltage using Ohm's law.